We're going to start with relative velocity question 2 from the 2019 paper. So for this question 2 here, it says that a man walks at a constant speed of 4 kilometers per hour from west to east on ground level. The wind appears to the man to come from a direction of north 50 degrees east. At the same time, a woman walking in the direction north 40 degrees west and also walking at 4 kilometers per hour notices that the wind comes from the north. Find the magnitude and direction of the velocity of the wind. So these questions are very general. They're always follow this format. You're always going to get 2 specific pieces of information, and then we're going to have to create 2 separate equations and then find an unknown value. So take a look at our hints here. The first one is, we remember from the start of this topic that it says that the velocity of A relative to B is the velocity of A minus the velocity of B. Now we can use that in these questions, and we can say that the velocity of the wind relative to the person is equal to the velocity of the wind minus the velocity of the person. So the second hint then that we're looking at is when we see the phrase "the wind appears to blow," that's then trying to tell us that this is the type of question where we're going to have 2 pieces of information and that we're going to create 2 equations. And then we're going to finish that off, we're going to let I equal I or J equal J, just one of them. And from there then the magnitude and direction is found by using Pythagoras' theorem and the tan inverse. So let's go now and take a look at how that is done. So again, we have our question at the top here. Now I'm going to work with the first equation, and the first equation comes from the first sentence. It says a man walks at a constant speed of 4 kilometers per hour from west to east on ground level. The wind appears to the man to come from a direction of north 50 degrees east. So we need to resolve these and write them as I and J in terms of I and J. So the first thing to notice here is that the man is walking at a constant speed of 4 kilometers per hour. So they tell us his speed from west to east. So that means that he is heading in the direction of east, which means that he is going in the positive I direction. Because if we have our drawing up here at the top with our north, south, east and west, up here are our J values and here are I values, the same as you would have on an X and a Y axis. The negatives are over at the west and the positive are over at the east. So if we're going east, it means we are going towards the positive direction. And how we find that is we're saying that this is the velocity of the man. So if I go over to my equations, which is here, I can see that the velocity of the man is going to be 4 i's because he's going in a positive direction 4i. And then there is no talk of him going north or south or at any specific angle. So it's plus 0j. The second bit there, it says that the wind appears to the man to come from a direction of north 50 degrees east. Now I've drawn out this little diagram here. If it's coming from a direction of north 50 degrees east, I draw my orangey kind of line there of north 50 degrees east. That's going from north 50 degrees east. And it's going from there, so that means it's going in this direction. It's going down towards west and south. So from that then, I'm going to just use the very basic opposite angles there. If that's 50 up at the top, then that means 50 is also going to be at the bottom. I have my I's and my J's. I know I don't know a speed here. So when I'm writing out, this is now the wind relative to this man. I'm going to say, well, it's going west, which is minus I's, south, which is minus J. So I'm starting with 2 minuses. I don't have my speed, so I write in my U value. Because the I value is this one here, that's going to be my opposite. I know that this is U, that's my hypotenuse, so I can use sine there. Sine of my angle of 50 is equal to my opposite value, which is what I want, all over my adjacent value, all over my hypotenuse value, which is the U, the value of the speed. And that's where the U sine 50 is coming from here. The exact same thing happens with the cos value. And it's always going to be, if I have this angle here, I'm always going to use sine because that's opposite and cos because the other one is adjacent. And that's where I'm getting this from here. I then use this rule here, that the velocity of the wind relative to the man is the velocity of the wind minus the velocity of the man. I have these 2 parts of it here. So I'm going to get the part that I don't have on its own, which is the velocity of the wind. And that's what we're looking to find. The magnitude and velocity of the wind. So I change my equation around so that I have the velocity of the wind that's equal to the velocity of the wind relative to the man plus the velocity of the man, and that is just using algebra, changing that equation around. I'm taking this, I'm moving it over, and it's becoming a plus. And in goes then my different parts to this. I have my velocity of wind relative to the man goes in first, and then plus the velocity of the man. All I do then is I match the i's with the i's and the j's with the j's. So I will have the 4 minus u sine 50 that's coming from this section and this section. And then the j values are the same, but this one here is 0, so it makes no difference at all. It's just the second part of the u cos 50j. So there's my first equation. That's my first section of this done. The next thing then I do the exact same thing to get the second equation, and this time it says that at the same time a woman is walking in the direction north 40 degrees west. So she's walking in that direction. So when I'm drawing that out here, I know that that is the direction that she is going. So she's going north 40 degrees west. And I draw that then, and again my i's are going to be the sine and the j value is going to be the cos. I know that that is going in a negative I direction, but a positive j direction because it's going up towards the north. So when I'm writing out the velocity of this, and I wrote F for female because I don't want to write the velocity of the woman because that would be V of W, although we already have V of W for the wind. So just take note of that. That V of S is because I already have V of W for the wind. I'm using the same idea as above. I'm using this here, so I still need to get, now that I have the velocity of the woman, which is minus 4, because they told me she was walking at 4 kilometers per hour, sine 40i plus 4 cos 40j. I now have to look at the second piece of information from up here, and it says that she notices that the wind appears to come from the north. So it's coming from the north, that means it is going south. If it's going south, it means it's a minus value, and if it's going south, it's a minus j value. So in this case, there are no I values. So here, the velocity of the wind relative to the woman, so the way that the woman is seeing it, is 0 i's minus v is a different speed because we don't know the speed that she thinks the wind is going at, and then j. So again, I fill in this formula here, which is the same as above. I twist it around to suit myself because I want the velocity of the wind equals, and I fill that formula in. In for the velocity of the wind relative to the female is this one. In for the velocity of the female is our first one with our sine 40 and our cos 40 in it. In it goes into that equation, and I get the velocity of the wind to equal this thing in the orange box, minus 4 sine 40i plus 4 cos 40 minus v, and then that's j. So from this stage now, we have done the first two parts, we've used the first two parts. The whole point of doing those two things was that we either match the i's or the j's. Makes no difference what two. I've happened to match the i's in this case, but you would get the exact same answer if you had matched the j's. And what I mean by that is letting this part equal to this part, or letting this part equal to this part. So that when I do that, I have my 4 minus u sine 50 equals minus 4 sine 40. Leaving out the i's, that's just telling us which ones to match with. So that when I do that, that's this bit here. I'm going to just move stuff around. I want to get u equals, so I move this to the right hand side, it becomes a plus. I move this to the left hand side, it also becomes a plus. I then divide across by sine 50. This whole thing goes into the calculator, and I end up getting 8.578 kilometers per hour. All I've done there is I've found u. I haven't actually answered my question. So the whole point of me finding u was to go back up here, and now into this equation I can substitute u in, and I will find what the velocity of the wind actually is. So when I do that, I substitute in here, and I end up then in my calculator putting all of this in and getting minus 2.57. Same for this part on the right hand side, the minus 8.578 cos 50 into the calculator, I get minus 5.51, and that's my j value. And again, we aren't finished. All this here is, that is the velocity of the wind in terms of i's and j's. We want the magnitude and the direction, and the magnitude and the direction is gotten by using the Pythagoras' theorem for magnitude and tan inverse for direction. So remembering now, if I drew this out, it would look something like this. That's where my velocity of my wind would be going. That means that to get what the angle is, I'm looking for where the opposite is the I value and the adjacent is the J value. That's why I have the O and the A here. The O being the I value and the A being the J value. In for this, it goes the first one squared and the second one squared, and the square root of my answer gives me 6.08 kilometers per hour. That's my magnitude. And then the direction, like we were saying there a second ago, I've put it into the tan of the angle. I do tan inverse of this bit here, and I end up getting 25 degrees. Now there's two ways to write that. I can either write that 25 degrees west of south or south 25 degrees west. Either of those are perfectly correct answers. And that's the first part of that question finished. The second part of this question then, part B, it says here that we have a rescue boat. Zoom in a little bit more. Here we have a rescue boat whose maximum speed is 24 kilometers per hour. Is 18 kilometers southwest of a fixed point P. There is a constant current of 4 kilometers per hour flowing uniformly in the direction south 30 degrees east. The rescue boat sets out to get to P as quickly as possible. Find the time to the nearest minute to reach P. So let's take a look then at a couple of hints for this. For this kind of one, if you're talking about needing to get to a specific location, so to get to another boat or to get to an island or to get to another airport or something like that, if you're in a plane, you have to make sure that your diagram is correct. So that's going to be the most important part of this. The diagram needs to be correct. The first thing is you need to make where you are going the origin. So if they're talking about you're sitting in a boat or you're sitting in a plane, where you are going to, or they're asking you to go to, that is your origin. That's where you're going to draw your little X and your Y axis on top of that point, and that point is going to be your origin, your 0, 0. The next thing then is you need to check and see if you and your destination are being affected by the current or by the wind or whatever it happens to be. If you're both being affected by the same current and the same wind, then that means that they're affecting both at the same rate. So that means that they don't particularly matter. You just ignore them and work using just distance, speed and time. Whereas if they are being affected, what we have to do is we have to create a triangle and use sine rule, cos rule, sine, cos, tan to find the angles and find the sides that we want. So let's take a look at B part 1 again, and we'll start to draw it out. So we have a rescue boat whose maximum speed is 24 kilometers per hour, is 18 kilometers southwest of a fixed point P. Now if they say southwest, that means it has to be at 45 degrees. It has to be exactly in the middle. So that's south 45 degrees west. So that's 45 degrees on each side. So what I've done here then is I've drawn boat B, and I know that I'm trying to get to point P. Now I'm trying to get to point P, so that means that's where my origin is going to go. And my boat B is going to go out, and it's going to go 18 kilometers southwest of the fixed point. So I've drawn my boat, I've drawn it about 45 degrees south of west from P, and I've made my little X and Y axis in that kind of mustardy colour there. The next thing then that I've done is I know that there is a constant current of 4 kilometers flowing uniformly in the direction south 30 degrees east. So that's the next thing that goes in. So my first thing that I've drawn is the boat B and the point P. I've drawn my X and my Y axis and my blue dotted line going from B to P. The 18 doesn't go down there because that's a specific distance. This here is talking about kilometers per hour, so we're going to just put on our speeds on this and our angles. What I'm looking to really find here is how fast is going from B to P. What is that actual relative velocity there? How fast are we actually going towards that one in comparison to us having to go a certain distance, certain way for it to pull us back, for the wind to pull us back towards P. So that's what we're doing here. It is told me here that the blue line, this blue line coming straight down here, that is the wind, and it's going at 4 kilometers per hour. So I have its speed and it's going in the direction south 30 degrees east. So you can see I've put in my little 30 degrees in there, which means that this has to be 60 degrees because that's a right angle. I've drawn that in, and then I've also labeled that is 30 degrees in case I might need it. I also know that this part is 45 degrees, so I've put that angle in too. So now I have my dotted blue line from going from B to P. I have my current going down towards the south there. The last thing I need to do is I need to figure, well, what way am I going to go? If I want to go to P from B, am I going to go in this kind of direction or am I going to go in this direction? Because if I am being pushed by the current away from it, I'm going to go in the opposite direction of the current. So that's why I'm going up here towards this direction. There's only two options for this. You're either going to go this way or this way to create a triangle. So just think about it logically and think, well, if the current is pushing me this way, there's no point in going down here because I'm only going to go further away from P. So I have to go to the left of my line BP to make sure that I end up back at P because the current is pushing me that way. And that line then, they told me the rescue boat is going a maximum speed of 24 kilometers per hour. So that's going at 24 kilometers per hour. It says the rescue boat sets out to get to P as quickly as possible. So I'm going to go at 24 kilometers per hour. It's asking me to find what time to the nearest minute I reach P. So what I need to find here is I need to find how fast I'm actually going in this direction. Because I know that that's 18 kilometers. So if I can find how fast I'm going that way and I have my 18 kilometers, I'm just using basic distance, speed and time. Now that I've created my correct diagram, what I'm going to do is I'm going to just use the leave insert stuff that I've learned, my sine rule and my cos rule, to try and figure out, because there's no 90 degrees here. What I have is I have 105 degrees in a triangle and no other angle. I have two sides though, so what I'm going to use is I'm going to use the sine rule. And that's going to find me another angle. The angle that I'm going to find is down here. And once I find that angle, then I can try and figure out what this length is using another rule. So my sine rule is going to be the sine of the angle over the opposite side, or the other way around. I could have the 24 over the sine of 105. That's the same thing. It makes no difference at all if you put the angle on the top the sine of the angle on the top or the sine of the angle on the bottom, as long as you do it on both sides of the equals. So sine of 105 over 24 equals sine of x, and I'm going to call this x here, over 4. I'm going to cross multiply, I'm going to get the sine inverse, and I end up then getting x equals 9.26. And that's that angle there, that's 9.26 degrees. Okay, that means that I can now also find this angle by doing this here, just taking away from 180, and I get 65.74. So in here goes 65.74 degrees. Now I have all that information. Really what I want to find is the speed of this here. I'm going to call that V. If you look at part 2, I've used the cosine rule. You could have used the sine rule. It makes no difference at all. But I put all of it into the sine rule to find this speed here. And it's going to be V squared is equal to 24 squared plus 4 squared minus 2 times 24 times 4. That's all from here. Cos of that angle, and that angle is the one in between the 24 and the 4. So it's the cos of the angle in the middle. All of it goes into the calculator. I get V squared and I end up getting the root of my answer, so that I can end up getting 22.65 kilometers per hour. That means that I'm going a speed, really my actual speed in that direction is what I've just found, the 22.65. So I've done all of that work there just so that I can use now part 3, my distance, speed and time formula from a junior cert. I know I'm going a distance of 18 kilometers. I know my speed is 22.65. I'm using my distance, speed, time formula. In it goes, and I end up getting this. They have asked me to the nearest minute in my question. So that means that I need to change it to minutes by multiplying by 60, which is what I've done here. And I have 47.68, which is 48 minutes in total. Okay, part B of that then, if we go back to the question up here, it says a yacht is in distress near P, and it sends a signal to the rescue boat. When the rescue boat arrives to P, the yacht is 6 kilometers north of P and is drifting with the current. The rescue boat sets out from P to reach the yacht as quick as possible. Find the time taken by the rescue boat to reach the yacht. So the first thing I notice about this is that I'm at P now. I know that's directly north of me, and I also know that this yacht is drifting at the current that I will also be moving at. So once they're both moving with the current, they become irrelevant, and what we say is that we're going to go directly 6 kilometers. We know what my speed is, My speed is 24, it's my maximum speed, because they want to get there. If I go back to the question, they want to get there as quickly as possible, so they're going to go their maximum speed. So all I need to do with that one there is, because they are both moving with a current equally, then the current is irrelevant. So that's just distance, speed, and time. Time equals distance over speed. That's 6 kilometers over 24 kilometers an hour. That's 0.25. And again, I'm multiplying it by 60 to get it into minutes. And that's a total of 15 minutes that's going to take. And that's that question fully completed then. That's the 2019 question 2 for relative velocity.